I'm Joanna Huynh, and we're Team Check UR5. This is our senior design project where we programmed this UR5 robot to play a game of checkers against a human opponent. So our user can just play one side of a checkers game. They can move their piece and notify the robot that they have completed their move, and the robot will play a move against the player. So these checkers pieces are 3D printed and they're custom with markers on them so that the robotic arm can detect the markers and identify which pieces are which. And this robot arm is picking up the pieces using a magnetic gripper. Each of these pieces have a washer underneath it so that it can be magnetized and picked up by the robot arm.
Okay, so we're Team Elaborate and our product is Soma. Basically what it is, we're collaborating with the biomedical engineering design team to basically redefine the electrolarynx, which is a device a lot of people who have gotten their larynx removed use to communicate with others. And so in order to make it not sound as robotic, the BME team focused on the physical prototype, or we designed the app for it. So we have text-to-speech functionality, also Bluetooth compatibility, so they can pair with a different Soma device, as well as they can control the volume of it, and even if their battery dies on their Soma device, they can still use their phone, and they can have so if they switch devices or phones or any mobile device, they still have their settings and their own personal AI or machine learned voice to perfectly, that continues to learn so it sounds more natural to other people.
Okay, hey, hello, we're Team RV for Life, and this is a RV Life Planner. We were tasked with making an application that can help users create a vacation plan. So we predict which bus stop they're going to go like throughout their vacation. So the user can just be like, okay, I want to go here. Where should I go next? We make a prediction for them. So right now it's at Arlington, Texas. And you can see in Arlington, Texas, there are all these different bus stops you can take. And right now we actually have the heat maps enabled as well. So you can see the largely densely populated areas, possible bus stops where many people go. So the user can add that to their current trip by clicking that, and that their trip can be visualized this way. So as you can see from Arlington, Texas, there's a path going to the location which they selected.
All right, so this is the War Driving Drone team. We're sponsored by Elbit Systems of America. This is our drone, and it flies autonomously and scans Wi-Fi access points and maps them on a GUI interface that we made. The next step would be to go over and have a hacking sequence where we go over and hack those Wi-Fi access points on a second mission.
Okay, so this is Team Folivora, and we made a small roguelike adventure game. Roguelike is a game in which every run that the player does is randomized and has randomized elements. So the point of the game is to get as far as you can and get a high score without dying. As you go through the game, the player will get stronger and get more abilities. And that's basically it.
Okay, so we're Team OmniPin. Our project is a VR pin that you can use in 3D space. Currently we have it using Unity. So we have a couple components here. We got a couple buttons that do different things inside the environment. We have one to draw, one to open and close a menu, and one to recalibrate to point it back towards the front of the screen. So we're using a few components in here, mostly Bluetooth to talk between these cameras and the computer, as well as a IMU, which is able to do positioning through rotation and magnets and stuff like that. So inside the program, we're able to select 3 different colors, black, white, and gray. We're able to select 3 different shapes, cubes, spheres, and capsules, as well as 3 different sizes of drawing. And then you're able to draw and move it around and see it in 3 dimensions, as well as change the color and shape and stuff like that. That's pretty much it.
So what we have here is a smart mailbox. With everything nowadays, everything is smart except for our mailbox, and so we needed a way to make sure there's a way to like check your mailbox without having to physically go out there and check it. So right here we have a web interface. So what it does is take video. If we were to open here and have something delivered, there's a camera on the inside with lights.
You've got mail.
You'll have a notification saying you got mail, and there's a video you play. You'll see it get delivered, and it'll update the history with the notification saying you have notification at what time and what date. And yeah, there you go. You don't have to physically go out there. Just take video.
Hello, and we are privacy preserving expression recognition team. So what we have is 4 sensors that collect muscle movement from the face. We determine if you're making an angry face, a neutral face, or a happy face. And so far, we have it running in real time. It has fairly high accuracy with only using a very basic model. And we're trying to, in the future, generalize this to work for medical rehabilitation.
Yeah, so we're Team Panda Drone. And so for our competition, we competed in the IEEE competition, which incorporated an autonomous rover, like we have here, and also this drone. And so the point of the competition was for the autonomous rover and the drone to act in tandem. So the rover would have to autonomously go through each box, send up the drone to identify each box, and then if it's the correct box, we go through it. If it's not the correct box, don't go through it.
Hello, we're Team Living Stream, and we use the concept given by the U.S. Army Corps of Engineers who sponsored our project. The whole idea was to take a living stream and bring it indoors so people that cannot access streams outdoor can have an experience where they can interact with fish and the waters of a stream. So we use Unity, which is called a game engine, where we made the whole stream, like you can see in the poster up there and over here. And our stream has fish that you can interact with. We used a motion sensor, which tracks your motion on the stream. So if I'm in here, like track me, and the fish will like react and like swerve away from me. So that's one part of our interaction. But overall, we use a projector that projects the scene, a motion sensor that tracks the scene, and we used Unity to make this whole interaction possible.
Hi, I'm Cameron from the Hologram Homies. We worked with the U.S. Army Corps of Engineers on a hologram display for their exhibit halls. Essentially, the idea was that you could go through one of their exhibit halls and press different buttons and activate different cues on projectors throughout the exhibit hall. And so we built that application to run those buttons, as well as a little configuration application to do some very rudimentary video editing. A lot of the idea was simplifying things as much as possible, making it as easy to run as possible, and also making it enjoyable for visitors.
Okay, hello. We are the Sawyer Robotics Cube team, and our goal here was to program a robotic arm in order to solve a Rubik's Cube. So basically it just takes a bunch of pictures of the cube, and so it can detect all of the colors for each of the faces. We put it into a program, and it tells us what commands to do in order to solve it. And we just program the arm to do a bunch of different poses so that it can move the cube around. And yeah.